Okay, so we're gonna talk about what is a moon. What is a moon? Well, on each of the research slides that we did the other day, we talked about that there are some planets have several moons. How many moons does Mars have? Two. Who said that? You? Good. Two Mars. Mars has two moons. How many moons does the Earth have? One. Okay. Anybody remember how many moons that Saturn has?
672?
Well, it was 60 something, and then they added 20 more to it, so it's 82. Jupiter, 79 moons. Okay. And moons is not something unique here only to Earth, right? That's basically what that proves, right? Because there's other planets have moons. Okay, so what exactly is a moon? It's a celestial body that makes an orbit around a planet, including the 8 major planets, and then there's a dwarf planet. We talked about this video the other day. For you at home, I actually put a link to this video. You can follow that link. So a moon is also referred to as a natural satellite. Now, this is a satellite, but it's not a natural satellite. This is a man-made satellite, right? So this is not a moon. So there's a difference between a man-made satellite, which is put out in outer space by humans for various purposes. Okay, so that's not a moon. But what do these two? What do the moons and the man-made satellite have in common?
Metal.
Huh? Well, yeah, that's right. The moon has metal. It's made out of its core is made out of iron and nickel. You're right. Okay, so what about this? What else? What else do they have in common? What do?
They orbit around things.
They move around the Earth. They orbit around the Earth, right? Orbit around the Earth. Okay. Okay, so astronomers have determined that there are at least 146, and then you add 20 to that because this was done in like this presentation was done in like 2015, so that's 5 years. And then we said that last year scientists added 20 new moons, so you could make that 166 moons in our solar system, at least that. Okay, that's what scientists know of now. So how do you think the moons were formed?
Out of dead planets. They ate the dead planets.
Gravity pulled the rings of dust and gas that circled the planets together. Okay? All this dust and gas circled the planets, and little by little it pulled the dust and gas, and they started forming into balls, and the gravitational pull of that planet started making them go orbit the whatever that planet is, right? So whether it be Saturn, Jupiter, Mars, Earth, and so on, right? So gravity pulled the rings of dust and gas that circle the planets together. Gravity from that planet that the moon orbits. Okay. Okay. So we saw a video actually about many of the moons that we have in our solar system here. And the small terrestrial planets have few or no moons at all. You remember Mercury and Venus have no moons. Earth has one, Mars has two. That's the terrestrial planets. Now the gas giants have many moons caught in their gravity, and that's because they have more gravity. They had more gravity even in the beginning because they were so huge, they were so large, that they pulled more dust and gas into spherical balls that begin to circle their planet, right? Okay. Okay. Okay, so here's a fact here. There are 2 moons in our solar system that are even larger than Mercury. Jupiter satellite Ganymede and Saturn satellite Titan are the 9th and 10th largest objects in the solar system. Okay? And there are also 7 moons, including our own, that are larger than Pluto. Okay, so, and Pluto, again, is that a planet or is that not a planet? What did we decide on that? It's a what kind of planet? Dwarf planet still. Although scientists are rethinking that, okay? Maybe in a year or two, Pluto might be a planet again. Who knows? Okay, here's a question here, number 20, answer this question here, and we'll take a grade on these. Some of these moons are in fact able to clear out their orbits because of their size. So why then are these objects not considered planets? What do you have to do to have a planet? Do you have, it's not because they're not big enough, it's not because they're not made of gas, but it could be they do not have gravity of their own, or they do not orbit the sun. So think about this, what exactly are they orbiting? Are they orbiting the sun? No. Okay, so you're gonna mark C or D, mark your answer. Which one makes the most sense? Okay, if they're orbiting the planet, are they orbiting the sun? Okay, I'm gonna move on. Okay, so let's look at our moon here. So astronomers have been studying Earth's moon for a long time, and we're gonna focus on our moon a little bit later, a little bit more on our moon. Look right here, this looks like a big potato to me. It's kind of making me hungry, actually. And this is an asteroid, okay? And our asteroid is filled with tens of thousands of airless, rocky worlds that orbit our sun. And these celestial bodies are too small to be considered planets, and they're instead given the name asteroids, okay? Asteroids. Okay, so where are asteroids found? Well, many asteroids are in our galaxy. Many asteroids in our galaxy can be found in the main asteroid belt. And this ring of asteroids is found between Mars and Jupiter, okay? Between Mars and Jupiter. Mars is the farthest out terrestrial planet, and Jupiter is the first gas giant, right? So in between there is this belt of asteroids, and it's actually called the Kuiper Belt. And that's where all the asteroids are, or in our solar system, put it that way. Okay, so let's look at Vesta. Scientists have spent much time studying an asteroid named Vesta. And it's the second most massive asteroid in our solar system. And it's also the brightest asteroid visible from Earth. So if you know what you're looking for, and you could probably Google, and they'll tell you where to look in the sky at night, you might very well see Vesta. Okay, it's big enough to see, probably with a telescope, or maybe even if you got binoculars at night. Okay, so asteroid, moon, or planet? That's the question. Well, asteroids have much in common with planets and moons when it comes to what they're made of and how they look. So why would an asteroid not be considered a planet? And then why is an asteroid not considered a moon? Well, what could we say about why an asteroid is not considered a planet? Tell me.
Because it's too small.
It's too small?
Yeah.
Okay. What else?
Because they orbit around the planet and not the sun.
Okay, they're not orbiting the sun. That's good. That's perfect. Okay. So why is it not considered a moon? Is it orbiting a specific planet? No. So that's why it's not considered a moon, right? It would be orbiting a specific planet. Those asteroids are just kind of out there floating around the solar system, okay? Okay, so here's our question right here. Between which two planets can you find the main asteroid belt? There's two answers here. We just said it. There's between two planets, there's this asteroid belt called the Kuiper Belt. Which two planets is it? There's two answers there, so mark those two planets. You're going to mark two answers here. Between which two planets can you find the main asteroid belt? Mark two answers there. Should be an easy one. We just talked about it. What were those two planets? What were those two planets? Where are they found? Okay. Okay, so I'm going to move on here. Okay, so asteroids are most similar to which planet listed below? If an asteroid. Okay, would it be more similar to Venus? Would it be more similar to Jupiter? Would it be more similar to Neptune? Or would it be more similar to Uranus? Now, here's the question. What's it made of? Is it made of something similar to Venus, or more like Jupiter, Neptune, or Uranus? What's it made of? Okay. So asteroids are most similar to which planet used below. You can either choose Venus or Jupiter. Can't choose Neptune or Uranus. I'll narrow it down for you a little bit. Okay. Hang on. Okay, everybody got an answer? Okay, let's move on here. Okay, so what is a comet? Okay, what's a comet? Let's talk about what a comet is. We talked about asteroids, and asteroids are big rocks, okay? That's what they are, bottom line, big rocks. Okay, let's talk about comets now. So comets are cosmic snowballs of frozen gases, rock, and dust. Okay, it's just kind of like a dirty snowball, right? A dirty snowball. And so they aren't just snowballs, though, they're much more. And you can see one right here. Here's a comet off in the distance. And so what do you notice about this right off the bat that makes it different from a snowball? What's the difference? Take a look at it and we'll talk about it here in just a second. What's the difference? Hmm?
They glow.
It's glowing. Who said that? I like what you said there. Good. It is glowing. Good.
It has
It's
a
glowing.
tail.
It's glowing. It has a tail. Yep, has a tail. Mm-hmm. What else? Tell me. Okay, so let's move on here. So it's glowing, it has a tail, and somebody said something else. What was the other thing you said? It's glowing, has a tail. It's huge, for one thing. It's huge, right? Okay, so let's move on here. So when comets orbit near the sun, the rock and dust create a giant glowing head, as well as a tail. Put those away. As well as a tail behind the comet. Okay. Essentially, the sun is melting. You know, the heat from the sun when the comet's facing the sun, and it's causing like a fizzle. Actually, is what it amounts to. Part of it's melting and then the farther away it gets from the sun, the lesser that's going to melt, right? But the closer it gets to the sun, bigger the glow, longer the tail, because it's melting. The heat rays from the sun are melting. Okay, so let's look right here. The nucleus. Okay, so these are the physical characteristics of the nucleus.
I'd like to get hit by one of those.
Okay, the nucleus is composed of rock. Well, Mr. Hughes. I know it's here. Please put the money away, whatever that is. Put it in your pocket, or I'm gonna take it. Nucleus is composed of rock, dust, water, and ice, and they have irregular shapes, and then they're described as a dirty snowball, right? Okay? Remember what the nucleus is. It's composed of rock, dust, water, and ice, and it's known as a dirty snowball. Okay, and then you have a comma, or a coma, depending on how you say it. Some people, I've heard it both ways, comma and coma. Mr. Hughes? There we go. Okay, so a coma, and this is the atmosphere. This is this stuff right here. See all this stuff right here around it, the fuzzy stuff. And that's the coma, or comma, is an atmosphere that forms as the comet heats up and gives the comet a fuzzy appearance, and it's made of ice and dust. Okay. And again, that's basically because it's the rays from the sun are causing it to melt as it flows. So you got the nucleus, you got the coma or comma, and then you got the tail. And the tail, that becomes visible as dust reflect the sunlight and the gases glow. And some, listen to this right here, some comets have a tail as long as 350 million miles long. 350 million miles long.
Mm,
That's a long tail, right? 350 million miles,
that's cool.
okay? Especially, anybody know how far we are from the sun, Earth? 93 million miles. So if you got a comet that's 350 miles long, the tail, that's a long tail, okay? That's a big comet. Okay, so comets in history. Well, throughout history, comets have been noted repeatedly. Writers have written about them, right? Go all the way back. Ancient civilizations felt these objects in the night sky, predicted bad events or disasters to come. The word disaster even can be traced back to the late 16th century from an Italian word, disastro. Look what it's got here, astro, which means ill-starred events. Astro in Latin, or in Italian is a Latin-based language, is astro, that means star. So disaster, or disastro, which means ill-starred event. So way back when, comets were viewed as bad signs. Something bad's gonna happen, okay? And actually, back in the ancient times, a lot of bad things did happen. So if someone's seen a comet, a comet, they could say, well, a bad thing's gonna happen. And well, sure enough, bad things happen, because that's just the time period, okay? And bad things still happen today, right? So you could still attribute that to that. Okay, so look right here. So write down on your calendars, remember this following date right here. July 28, 2061. Okay? If I'm around, I'll be 106. You'll be around, though. You'll be around. July 28, 2061, that's the next time that Halley's Comet is expected to be in our view here on Earth. How old are you gonna be in 2061? Sophia?
I think
Mine is old as gold.
Sophia, how old do you think you're gonna be? What year were you born?
2007.
Okay, so 2007, so you'll be what, in your 50s? Late 40s, early 50s? So you'll all be in your probably 50s, right?
Yeah.
2061?
I won't.
Okay, you'll be in your 50s.
Or 40.
You will be, yes.
I won't because my birthday is April the Fools, and I was born
What year?
2018.
Huh?
I was born 28.
2008?
Yes.
Yeah, 2008.
And I'm still 12.
Yeah.
How old will I be then? As old as adult. Probably my grandchildren will piss me around.
Maybe in your early.
Oh my 30s? I should be dead by then.
Okay, so Halley's Comet, 2061. Okay, so here we go. 23, a comet is most like which of the objects below? Is it more like an asteroid? Is it more like a planet? Is it more like a star? Or is it more like a snowball? You can choose star or snowball. C or D, mark your answer. C or D, mark your answer. A comet, is it most like a, is it most like a snowball or a star? Everybody got an answer? Good, I like that. Okay. Okay, so let's move on here. Okay, look right here. So as a comet soars overhead, you can most easily see the remains behind it, okay? And so what part of the comet are you most likely seeing stretched across the sky at that time? Okay? Are you gonna see the coma, the nucleus, or the tail? It's most easily see, what remains behind it? Is that the coma, the nucleus, or the tail? Which is behind it? That's how you can gauge that answer, what the answer is. Okay?
Oh, my
What?
my sister has one of these walls.
Mm-hmm,
Well, look,
mm-hmm,
I should still
mm-hmm.
sell eBay.
Okay, okay, let's move on here. Okay, so let's look what a meteoroid is. What's a meteoroid? What is a meteoroid? What's a meteoroid? Okay, let's look at what meteoroids are. And here's a piece of one right here. I don't, well, this came from, so NASA has it. So meteoroids are small chunks of rock and space junk that can be as small as a grain of sand or as large as a boulder which have not entered Earth's atmosphere. Okay? So they can be as small as a grain of sand, and actually, if that grain of sand were to make it to Earth and hit your skin, guess what it's probably going to do?
Killed you.
No, it's not, maybe not kill you, but I promise you, it's probably going to go all the way through your skin.
Oh yeah, I was watching 911 and then this girl was
Okay.
like laying on a couch and then an asteroid came and like went like through her and then like somebody said.
Okay, let's look right here. So meteors, okay, we talked a little bit about a meteoroid. So a meteor, there's a good chance you've seen a meteor in your own lifetime. Anybody know for sure you've seen a meteor?
Nope.
Okay, so what's a meteor? Well, you can see these right here. Anybody know? No one's ever seen this ever. You have? Okay, so let's look right here. Okay, so meteors are also known, well, the meteorites. They're also related to meteoroids and meteors. These two photos can give you a hint about what a meteorite is. A meteorite is something that actually lands in Earth, okay? Meteoroids are in space. Meteors are what you see when you see them showering down at night, if you've ever seen it. And usually, when they're showering down, they usually burn up, okay? But occasionally, oh my Lord, I wouldn't want to be under that one. That one made it to Earth.
Oh, I would
Ooh.
love to get hit by
Oh
that.
boy, yeah, that one made it to Earth. I don't know how big that is. They'd have to show something. I don't know if that's like that big or if it's that big. I don't know. But the meteorites are parts of a meteoroid that actually makes it to Earth and lands on Earth. Okay. If we have time, I might show you some meteorites coming in. Okay, so let's look at the difference between meteoroids, meteors, and meteorites. And I'm going to show you a video here of that. For you at home, I'm going to put a link to this video here.